Hello students, I, Ms. Pooja Kalange, Assistant Professor IISMR MCA, welcome you to this capsule program. In the previous capsule program of day 1, we had covered the basic concept of association and we had seen one example, so how to implement the association and how it is actually being done at the real time. So there was one example which I've already covered. Now in today's lecture or in today's video lecture series of capsule program, we will be covering the concepts of classification and the concepts of clustering. So let's get started. So in today's lecture, we will be covering the classification clustering techniques, right? So but before going on to this, we need to know what are the basics of classification. So classification is one of the supervised learning methods. So I have already told you what this mean by supervised learning. You know what would be the input and the predicted output. So basically classification will help you to distinguish a particular data class. Means for example, I, as a teacher, want to classify students based on their streams in order to understand what would be the level of understanding the computer subjects. Like I would classify students as BSc, BCA, BCS, BA, BCom. So this is a classification technique. In the similar way, I could classify students based on their marks, right? So basically, classification will be nothing but problem of identifying the sets of categories, right? I've made some set of categories in the predefined way, and now I want to see how will be the membership or the association made between these entities. So what will I do? I will have a training set and I will have a testing set. Training set means I've already trained the samples and there will be some unknown sample. I will try to test it with the existing sample. Okay. So in this case, based on the training set of data, which is having observation, you will know the categories whose membership would be known. Means for example, I'll tell you one simple example. I have a data. Okay, in that data, I have students, 60 students. I have classified them based on their percentage. Okay, now there comes one person. Okay, so there are four classes. For example, class A is more than 90%, class B is between 90 to 70%, class C is between 7 to 70 to 50%, and class D is below 50%. Okay, now there comes one unknown student whose labeling I have not done. For example, okay, and he has secured 80% marks or maybe more than 80% marks. So I know that if his marks are 80%, I need to put him in the class B. So how did I understand that I should put him in class B? Because I've already defined a label that if the student mark is between 90 to 80%, he should be put into the class B. So the same technique applies in the classification as well. So how will I do this actually, right? So there are some algorithms which are being used in classification. We have KNN classification, which is one of the important algorithms which is being used in classification methods. So let's see actually how these things happen in classification, right? So I hope this picture is familiar to you. What can you see in this picture, right? You can see there are pulses and dals existing in this picture. So how will you identify here each and every class? For example, this is class A, this is class B, this is class C, this is class D, this is class E, F, G, and H. In total, I have here existing 8 different classes, and each every 8 different classes have different properties. For example, if you see this chana pulse, this is chana, this is having a brown color. If you see this urad dal, okay, this is having the white color. If you see this green gram, it is having the green color. Okay, so these are different variations of dals here. Okay, now if there is some x dal or any x item coming in between, how will I identify it belongs to which class, right? So that is my main problem. I need to classify the data items. So I know the training set. Training set is already present with me because I know these, they have their own properties, they have their own characteristics. Now, how will you classify a dal? You can classify a dal based on taste. You can classify based on the appearance, based on the color, based on the shape, based on the size. So there are many attributes which can be used in classification, right? Now here if I consider this is having good color attribute, right? So if a dal is having pink color, I can say that this is the Bengal gram. I can use this, right? So in the similar way, classification, how will it work? Now let's see, okay? So if you see here, this is an object, okay? This is an unknown class or it's an unknown, you can say label. I don't know what is this object related to. But now you want to identify it belongs to which class. Now if you see this technically, the pointer or the object is placed in between these two, right? This is between the yellow gram, you can say yellow gram, and this is the chana, right? The chole dal, actually you say. So I have to check whether it belongs to this part, it belongs to this part, or whether it belongs to this one. So how will I do that? It's very simple. You need to check the nearest neighbors. That is called as KNN classification. K, nearest neighbor classification. So how will I do that? So the basic requirement is you need to have at least two neighbors, two to three neighbors. Then only you can make the classification. Means either one true and one false. Okay. If you have only one neighbor, you cannot detect it belongs to which class, right? So for that case, a simple technique is you need to check the diameter, your neighbor diameter. Okay. So how will we do that? So if you see here, there is a circle being marked in this diameter. Now, if you see the previous picture, it is very difficult for you to identify to which class it belongs, right? But now if you see this picture, you can calculate that the maximum class or the maximum dal or the label of pulses and dals is coming from this part, right? This is very lesser and this is a mix of it. So I can say that by probability, this unknown X value or this X dal may belong to this part. Why? Because these are more items present in this. To make this concept easier to you, see, this is an example. This is an unknown dal, as I said you, okay? This is the shapes, okay? I have taken here, this is the star shape, these are the triangle shapes. Now, I want to check this unknown square, whether it belongs to this star or whether it belongs to this class B. So, this is class A star class, and this is class B, that is triangle class. So, I will mark a diameter radius. So, if you see here, there are k is equal to 3 means nearest neighbor value taken is 3. So here I can see there is only one red star and there are two triangles, right? So the majority is for triangles. So I can say that this unknown square, yellow square, it belongs to the class B of triangles. So that is nothing but the KNN classification. The same concept I have told you in terms of these dals. So if you see here, you can see that this is showing the maximum count. This is a bit lesser and this is a mix, right? So from that, I can predict that this X unknown X value belongs to this class. Okay. So I hope I'm making this concept of classification clearer to you. So based on this same concept, all the algorithms in classification are being implemented, which are eventually used in our data mining. Okay. So here this nearest neighbor is how much? 3. If you consider 7 neighbors, now if you see here this is k is equal to 7, then it goes into longer diameter. Here you can see only one green triangle. Okay, and now here you can see there are 3 red stars. But now you can see that this does not belong to class B, but it belongs to class A. So that is a major drawback with classification. More the number of neighbors, more the numbers of identification. So what it tells you, lesser data will not help you in accurate prediction. Greater the data, greater will be the accurate result and greater will be the correct prediction, right? So this is one important thing which you have to remember in terms of classification. Whenever you have a larger data set, you can have more classification done because they will be having more neighbors and more vicinity distance or the distance between the neighbors can be calculated. So I hope you are clear with this part of classification. Next, we move on to clustering. Clustering is one example of unsupervised learning. So you know what is unsupervised learning? You know what is the input, but you don't know what would be the output. So cluster is same as classification, but they are grouped based on same class. So clusters are made based on the classification. This is the important thing you need to remember. The similar objects will be grouped into one cluster. Means, for example, as I had shown you the previous example with association, which we had covered in a day one, right? All the products were belonging to cosmetics, right? Why? So I can make a cluster of cosmetics. Why? Because it was having face mask, it was having face scrub, it was having the face wash, it was having the talcum powder, it was having the brush. Everything was related to the face, right? So I can make it under the cosmetic section, right? So similarly, I've already classified the objects and now you're making a cluster of that, right? So that is similar objects are grouped together into one cluster. But the important thing in clustering is you know the input, but you don't know what would be the output of that. So the characteristics of similarity of data are not known to you unless and until you test that. So how will I do that, right? For that, we have K-means clustering algorithm, agglomerative clustering algorithm, which will be covering actually when we'll be starting our lecture. So just to brush up with that, this is one example, okay? You can see here, these are shapes. These are unorganized, okay? You don't know how to classify them. So how will you classify them? Based on the object size. So if you know it is green color, you will make a cluster of triangles. If you know it is a blue square, you'll make the another cluster. And if there is this red shape, you will make the third cluster, right? So in this way, this unknown data set of the unorganized objects is being classified into a proper data set. So that's why it is said to be unsupervised learning. You know what would be the input you have given, but what would be the predictable output, you can be only able to do it till only you classify them properly, right? Now for example, if you consider that if there is some unknown object coming here, so then you have to check that whether it belongs to this class of triangles, rectangles, or whether it belongs to the class of triangles, or whether it belongs to the class of circles, right? So that time again you have to check the nearest neighbor concept, or you have to check the distance between the existing classes. Okay, so this was the second part of capsule program, where we have covered the basics of classification and clustering. So I hope you are clear with whatever I have told you today. Okay, so I thank you for watching this video. Thank you.